Hello, in this example, we will be looking at how to merge two sorted linked lists and also compute the space complexity and time complexity of the solution that we build in JavaScript. Before jumping into the solution aspect of it, let's first get a quick glance of what the problem statement is. We will be having two singly linked lists. A singly linked list has two components to it: a value and a next pointer. And we form a chain of these nodes which form the singly linked list. In our input, we will be having a node pointing to the next node, which is like the value of the node, and then there is a next pointer, and we have the last node in the linked list that always points to null. So this is our list 1, and for list 2 we will have input something like this: 1 3 pointing to 4 pointing to null. This is null notation, and the head of the linked list is this one. The head pointer points to the first node of the linked list, and similarly for this one, this is the head node. And the problem statement says that given two singly linked lists which are sorted, as you can see these two are sorted lists, what we want to do is for output we want to have something like this. One will be pointing to the next one, then you have 2 pointing to 3 pointing to 4, and then we have two 4s here. So this 4 and the last 4 will point to null, and the head pointer will be pointing to this one, and this is the output that we are looking for as part of the solution that we will be building. And the function will be taking two heads as part of its input, list 1 and list 2. When we say list 1, it will be the head pointing to the first node, and when we say list 2, it will be the head pointing to this list, this element in the list. And we will be solving this recursively, recursive solution. And in this part, what recursive means is basically I will be calling this function again within itself, and then it will be going in a recursive call stack until we return something. Because in a recursive function, to be able to exit it, we need some exit conditions, otherwise it will just go in a infinite loop. I will try to represent the code aspect of it visually as we try to come up with the solution. Let us say we have list 1, which is 1 pointing to 2, and we have list 2, which is 1 pointing to 3. Let's just forget about the other nodes for now. Let's just focus on the two parts. So this is list 1 and this is list 1 dot next, because in the function list 1 is the head indicator. So this is, let's say, list 1 and this is list 1 dot next. Similarly, this is list 2, which is the head pointing to list 2, and this is list 2 dot next. Now, before jumping into the solution aspect, from visual representation I can see that this one, then you have this one, so this two are equal, so they should be together, and then if between this two it will be, this is higher, so it should be something like 1 1 then 2 and 3 for the sorted sequence that we want. And to do that, we can simply do something like this: list 1 dot value, which is this one in our case, is less than equal to list 2 dot value. Then we do something. What this means is I'm basically comparing the value 1. So in a function call 1, the first parent call, what we say is I'm comparing 1 less than or equal to list2.value, which is this one. And in this case, both are same. So it really doesn't matter if I return the first or the second if it is equal, but I also have a less than check. So if the first one is less than the second one, then you just return the first one. So what we say is return the first one. Otherwise, return the second one, because the second one will be less otherwise. And this is the core aspect of it. Basically, we say compare two values, and whichever is the one having the lower value, return that one. Now, if I just return it like this, there is not going to be any change in the connections between the nodes, which is not something we want. We want to also make sure we have the correct connections between the nodes. So what we will do is something like this. List1.next. List1 was this one. Right now it's pointing to this one. Instead of pointing it to this one, what we will say is this dot next value will be the outcome of a recursive call that we will make, and to that we will pass this value and this value. This value is list1 dot next, and this value is list2. So what we will say is merge two lists, list1 dot next comma list2. What this basically means is something like this. We are going to be returning this one, but the next pointer needs to also point to something. It's currently pointing to 2, and I am passing 2 pointing to something, and I am passing 1 pointing to something here. I know that the next pointer should now point to 1, because when I call it again, so let's say we call this again, function call 2, let's say. Now in the function call 2, you will say you have 2 pointing to something and then 1 pointing to something. This now becomes my list1, this becomes my list2. We will come here, we will say list1.value, which is 2, less than equal to 1. We will check this condition now fails. So now we will just return list2, which is this one. And when we return this one from this call, it's going to be basically something like 1 is going to be pointing to 1 again. And that's the critical aspect that we want to achieve here. Similarly, we just returned 1 pointing to 1, but now this next, which was this one, was still pointing to 3, which is not what we want. It's now should be pointing to 2 ideally. So now what will happen is list2.next is equal to, again we are going to make a call, and we will say list2 dot next, the value that we want to change, and list1 we pass as it is. So in the first condition we said take the next from list1 and just pass list2, and in this one we say take list1 as it is and pass the list2 dot next value. What does it mean is that when you make the third function call, it will be something like this value that we had, which was list 2 was pointing to 3 in the original list, and list 1, that is this value that we received, is what we are passing to this. So basically we will say is you are receiving 3 as list 1 now, and list 2 is what was being pointed by this one, which was this in the second call. So I will just say this is my list 2, and we were here, we were pointing to this. We don't want this, we want to have something else here. That's why we wrote this line, list2.next is equal to something else. And then in this one we will say merge to lists, and we will pass these two values in this function call, and this is my first value and this is my second value. And if you compare 3 is less than or equal to 2, it will return this one, 2. So this part returns 2. When this returns 2, that means list2.next, which was this one dot next, instead of it being 3 now, this will be gone, and this will be now pointing to this. So a new array will be 1 pointing to 1 pointing to 2 and 2 pointing to something. And if we do this recursively until we have elements, it will basically give us the sorted order and merge the two lists. But now it is just checking the values. There is no exit condition in this. A recursive function needs to have an exit condition, otherwise it will just go in a infinite loop. Now to tackle that problem, what we will do is something like this. If list1 is equal to null, just return list2, and if list2 is equal to null, just return list1. So when you reach the ends of the lists, it will just return the nodes which are from the other list, so that you exit the condition, and also it handles the edge cases wherein if you receive two lists and the next list is empty, you just return the first list. That means there is nothing to merge, and same vice versa as well. And that's pretty much it. This is the solution. And in terms of time complexity, it will be order of n because we are going recursively, and space complexity will also be order of n because we put calls in the call stack every time we make this calls. And that's pretty much it. Please like and subscribe. Thank you for watching. Bye.